Hello and welcome everybody to the network binary. Today we are diving into one of the very important and famous topic of the CCNA, and that is how TCP/IP and OSI model really work. So before we dive into that one, I have a quick question for you. Tell me, on which UDP port number does ICMP operate? Take a moment to answer your question or keep watching to find out. Okay, so today's agenda for this video is OSI and TCP/IP layers, how these are arranged, and the connection between them, port numbers, port protocol numbers, ether types, encapsulation concept that we are going to see here. So 5 points I'm going to discuss in that. So let's think about it that we have a PC or any networking device you can consider here. Uh, when it sends any kind of data to the internet, it follows the OSI model. OSI model is nothing but 7 steps. The detail you have already seen in the course itself. So OSI has total 7 layers. That is application, presentation, session, transport, network, data link, and a physical layer. All right. And then on other hand, if you want to understand the encapsulation mechanism, we have TCP/IP model. In that TCP/IP model, application presentation session of the OSI is combined into one layer, that is application layer, or sometimes this is also known as process layer. Then transport layer is the transport layer. Network layer's name is changed to internet layer in this model. And the data link and physical layer, these are combined together. And we call these things or these two layers as a combination network access layer. We already have seen some services and protocols in our course. So let's arrange them accordingly in this. We have HTTP. I'm talking about application layer now. HTTP, HTTPS, Telnet, SSH, DNS, TFTP, SNMP, and ping. Few names I have arranged here, but definitely these are not all. So we have some other services as well on the application layer. At the transport layer, we have protocols like TCP, UDP, VRRP, EIGRP, OSPF, authentication header, encapsulating security payload, ICMP, and other protocols also available. At the internet layer, we have IP, we have ARP, reverse ARP, Apple Talk, IPX, SPX, but Apple Talk and IPS, SPX, these are legacy. We don't use them now. So let's remove them and shift these 3 protocols at the center. At the network access layer, we have Ethernet and different types of Ethernet or layer 2 protocols, hardware protocols like Ethernet, fast Ethernet, and other types. So these are others. Okay, now let's try to understand what are the connections between these services and applications to the transport layer and internet layer in terms of encapsulation. So HTTP, HTTPS, Telnet, and SSH, these are known as the services of the TCP, meaning they need to come to TCP to put into its data, and then they go further. So we have DNS, which is based on TCP and UDP both. TFTP is based on UDP, SNMP, UDP, and ping packet internet grouper is not related to TCP or UDP. It uses its own protocol, that is ICMP we have. So initially the question which I asked to you, that was a tricky question. ICMP or ping does not use UDP at all. All right. So TCP and UDP, since they are using a lot of services, now question comes how they differentiate between or among the services. So the answer is that they use port number concept. So TCP uses port number 80. We have 16 bits of total port number. So 2 to the power 16, and you calculate and you get the number. So we have some well-known port number and we have some other port numbers which is used by the PCs here. So we got port number 80 for HTTP, 443 for HTTPS, Telnet 23, SSH 22. DNS uses TCP and UDP both port number 53. TFTP uses port number 69 of the UDP. SNMP uses 161, 162 again of the UDP. Ping does not use any port number, like I said, it uses ICMP types. Type 8 code 0 is for echo request, and type 0 code 0 is generally used for echo reply. We have an example in this video after this slide. So whatever you see here at the transport layer, these are protocols. So I already said it. So these are the protocols they need to encapsulate into the IP header. And IP recognizes them using the word protocol number. VRRP is protocol number 112, TCP is 6, EIGRP 88, OSPF 89, UDP 17, authentication header 51, ESP 50, ICMP is protocol number 1. And we have other protocols as well, which we will see time to time as we follow CCNA and CCNP. Now, this IP here is encapsulated into Ethernet, and Ethernet recognizes them using the word ether type, and that's written in hexadecimal value. IP is 0x0800, ARP is 0x0806, and reverse ARP is 0x0803. So let me give you one example how this encapsulation work if you use ping. So in our scenario here, we are using a PC, which is, somebody type ping 4.2.2.2. It is building some kind of data, encapsulating this one and sending it to the internet. Now let's see how it works. So you remember that table, what we just saw in the previous slide? If not, maybe you can go back to the video and take a screenshot there. So ping 4.2.2.2, this is encapsulated in ICMP, the ICMP in IP, and then in Ethernet. So this is the structure we have here. Now, on other hand, remember this thing that when we say ping ICMP, IP, and Ethernet, these are together, we collect them. So this is called a frame. So in the frame, every block has different size. Like ping, in this case, because this is Windows operating system and it depends on the operating system. So ping here is generating 32 bytes of the data, ICMP 8 bytes, IP 20 bytes, and Ethernet 26 bytes of the data. And if you add them together, it becomes 86 bytes. So the frame size here, which is leaving from my PC, is 86 bytes. But on the screen, what you see here is not the frame which I'm sending to the destination. This is what I'm receiving from the destination. That's the reason you see a reply from 4.2.2.2. And the data size which I'm getting in that ICMP is 32 bytes. And it took 72 milliseconds to come back to me, and TTL is time to leave, how many routers it is crossing. So 52 here, it means if the destination is Windows computer, Windows operating system, it will subtract from 128. If it is a Linux or Unix based computer, it will subtract from 64. So if it is 64 at the initial and I'm getting 52, so 64 minus 52, if you do, that's 12. So it's taking 12 routers to reach back to me. So there are 12 routers in between. Anyway, that's a different story. We understand that in troubleshooting section of our CCNA class. I just gave you a little bit idea. Come back to main topic again. So I was talking about encapsulation. So this is the encapsulation example we had. Let's take an OSI example in our case. To understand the OSI Model 7 layers, I have taken two devices. Here on the left, we got a PC. On the right-hand side, we have a server. And every operating system, which is any operating system which has a capability to go to the internet or to connect to the network, it has a network module, and the network module has TCP IP stack in it. Somebody has configured this OSI for HTTP and FTP. Sorry, I say OSI. Somebody has configured this server for HTTP and FTP here. Okay, so what does it mean? It means that the TCP has a lot of port number, but because HTTP and FTP service is configured or enabled, which means that port number 21 for FTP and port number 80 for HTTP is open, right? Anybody can connect to these port number through these port number to the service. On the other hand, on the client side, same situation we have. Operating system, it has network module and it has TCP IP stack as well. So it also has a lot of port number to select, but none of them is open right now. Okay. So next, let's say the IP address on the client side is 192.168.1.10 and on the server side is 1.50. There is a user on the client side who opens up the browser and when we say that opens up the browser, it means we are already in application layer of the OSI. Remember the 7 layers: application, presentation, session, transport, network, data link, and physical, right? So we are in application layer, browser is open, and then the user is, user type 192.168.1.50. That's a destination IP address, and it's using service HTTP in that case. Now, this HTTP, this is the first message. It has a get message inside it. And in that get message, this is in the text format. I'm saying text format. So this is the representation of the data. And to present the data at the destination or back to the application layer, we need something and we need someone's help. And this is the presentation layer, which helps us to understand the data, which actually helps the application to understand the data, right? So presentation layer is taking the data type here. So one more time, encapsulation is working together. So application layer done, presentation layer done. Now this HTTP goes into TCP for encapsulation. And when it goes to TCP, now TCP might have a lot of sessions running already. So it has to create uh, a session for this one. So what TCP does, it opens a random port number on the client side. On the server side, which port is open? 21 and 80. And on the client side, we have port number 129 opened as by the request by this URL or by this browser. So destination 80, as I said, so this is maintained because TCP has to maintain all the connections. So that is maintained by the session. So the session layer comes into the picture. TCP itself work in the transport layer, right? So this is the scenario up to application, presentation, session, and transport. Now this TCP goes into the IP, which means that this is in the network layer. And IP is a logical address which has a source IP address and destination IP address. There are other things also available into this one. We'll talk about that on some other day in detail. So this is the network layer. IP goes into the network, and the network the IP goes into Ethernet at the data link layer, and now it builds the frame after that. And in the Ethernet, we have source MAC address and the destination MAC address for the local communication. All right, let's summarize this thing, make it short. So we have HTTP, TCP, IP, and Ethernet. This is the frame we have. So this frame is at the layer 2, and the layer 2 converts that frame into digital signals for the physical layer. And physical layer send that signal, digital signal. So this is not binary, by the way. I have seen many people, they refer this as a binary, maybe because of the shape, but this is signal. Binary generally we consider within the computer, not on the wire, right? So this frame in the digital signal, it goes to the physical layer or at the destination. Now data link layer, meaning the LAN card, receives that digital signal and demodulate to the frame again. Now data link layer reads out the Ethernet header, finds out if this is for me or not. If everything is okay, then it strips the Ethernet header out of it, and then remaining part is sent to the upper layer, which is the network layer. Network layer also checks its header for the IP, and then if everything is okay, it processes this and send it to the transport layer. Now transport layer look at the TCP, and because this is the session maintain responsibility or session maintenance responsibility goes to the TCP itself. So TCP and UDP both, they does that with the help of operating system. Since we are taking example for the TCP, I'm just using the word TCP here. Okay, so session layer creates a session that somebody from this IP 192.168.1.10 is communicating to me. Source port is 1029 and destination port number is 80. All right. And then this HTTP, since it gets the text data, the presentation layer find out that, okay, this is a normal text. I can present it to the application. There is no any problem into this one. Probably it will understand it. So it forwards that get request in the text format to the application layer. And then application layer is going to process that request within the engine of this device, within this server, sorry. Now, I hope this is informative for you, and I hope you like it, everybody. Before I close this session, I would like to give you a few questions for your practice, and these are here. So take a look on this one, TFTP, TCP, IP, Ethernet. You need to tell me if this is true or false, right? The second question is here, true and false. This one again. So 4 questions for true and false. Think about it based on the encapsulation table, which we have seen in this video. And there is one more question I would like to give you. You need to write down the encapsulation for ARP, like we saw. We saw for the ping. Ping goes to ICMP, ICMP to IP, then IP to Ethernet. You have to think about the ARP, how this is encapsulated. You can write down your answer in the comment section here, and I will be waiting for your answers, and you will get the response on the chat itself or in the comment itself. Thank you, everybody. Have a great time.